Alright, so today I'm trying to teach you how to find the velocity of an object as it's in a trajectory. We got to do a quick review here on just terms. What does velocity mean? It's speed, but with one more thing. Yeah, with a direction. We want to know which way is it going. Now in a trajectory, I want you to turn to page 73. Let's look at this together. You're going to find a slide that you're going to find a picture on page 73 that looks like this. Now, as the object falls in a trajectory, what happens to Vx? It's constant because there's nothing pushing on an object sideways. So that's why we've got that arrow here and this arrow here showing the same length, because the speed sideways isn't changing. But the speed up and down changes just like it would if it fell straight down. So let's say we have a parachutist here who jumps out of a plane. He's going to fall in a trajectory, and wouldn't he be underneath the plane as the plane keeps flying? Because he'll drop down, but the plane wouldn't. Well, when the parachutist gets to here, and we're talking about before he opens his parachute, he will have gained a little bit of velocity down because he'll have fallen some distance from the plane. And he'll still have the same sideways speed he had when he jumped out of the plane, yes? His actual velocity then would really be that way. I mean, if you looked at him, you wouldn't think of him having two velocities. You'd think he's kind of going diagonally down, right? Not too far. He's not going very fast down yet because he hasn't had time to fall very long, so he hasn't gained very much vertical velocity. But if we check back on him later, after he's taken this path, he's still moving sideways, but he'd be falling a lot faster down because his weight has been causing him to gain speed towards Earth for more time now. Since he's going faster down, if you looked at which way he was moving at that moment, you might see it was that way. So the sideways velocity in a trajectory is constant, but because the downward velocity is always changing, the actual true velocity, the Vxy, is not only changing in amount, it's also changing in direction. So if we ask you to find the velocity within a trajectory, you can only find it in one spot at a time. You're saying at that moment, the object is going this fast in this direction. And what I want to teach you today is how to find that. Okay? So let's go back to our notes. Questions on this picture before we go to those notes? Okay. So in this kind of trajectory, we know that the VIY is 0 as the object starts because it's just going straight sideways. And from that picture I just showed you, as the object falls and takes this path, when it gets to some spot later in its trajectory, it would have a velocity that's both sideways and down. Now, if we wanted to find the velocity at that spot, we need to know both Vx and we need to know the speed up and down at that moment. Now, Vx is not hard to find. In fact, didn't you just find it in the ball in the cup problem? And because Vx doesn't change, once you found it, you know it for the rest of the problem. Now, at that spot here, if we wanted to know the vertical velocity, we'd be looking for Vfy. Why is a Vfy? That's the final velocity because it's some speed that happened after the trajectory has already happened. Now, it's not going to be 0. If the object is moving in that direction, some of its speed is sideways, but isn't some of its speed down? That velocity will be negative because the object's moving down. If we want to find that velocity out at an angle then, what we need to know is both Vx and that Vfy. They can be calculated, or they might be given. But we have to know both if we're going to find the velocity at an angle. Simply as a reminder, when you go to find Vx and you go to find Vf in the y direction, you still have to run two separate sets of calculations because you can't mix x and y information in the same equation. All the equations that you have work only side to side in the case of dx equals Vx over t, excuse me, Vx times t, or all of our acceleration equations work up and down. So that what I taught you last time, still there. Can't mix x and y information as you're trying to find these two things separately. Now, isn't that velocity, though, reflective of the fact that it's moving both sideways and down? So once we can find Vx and Vfy separately, what I'm about to show you is how you would find Vxy, that velocity at that moment. It's really only useful as an endpoint. You couldn't calculate anything with that velocity because it's been changing both in amount and direction the whole time through. But you can find out at that moment how fast it's going. Let's do one more review of terms before I show you how to do that, because part of the problem on the trajectories test will be, do you know what to solve for? You have to read the problem carefully. So here's our review of terms. All right. Velocity is speed with direction. Within a trajectory that looks like this, if we're looking at the path, if I ask you to find the velocity here, what direction is it moving? Horizontally. So if I say find the velocity, but you know that where you want to find the velocity is there, all you'd have to solve for is Vx. But if I asked you to solve for the velocity here, is it still moving sideways? Yes. But isn't it also moving down? So you'd have to solve for both and then do what I'm about to show you to find Vxy. Now what if an object simply fell straight down? And we asked you to find the velocity here. What direction is it moving? Down. So you'd be looking for what? Vfy, the final speed after that fall down, because that's the only direction it's moving. Now, pretty soon we'll start problems where the object might go up to start with, so it would take a trajectory up to the top and then fall back down. Right as the object started its trajectory and started going up, if we asked you for velocity, then what would you be looking for? Viy, because it's moving up at the start of its trajectory. What we want to caution you then is, if we ask you for velocity, that could be Vx, it could be Vfy, it could be Viy, or it could be Vxy. It depends on the direction the object is moving. You've got to just use some reason and look at the trajectory and say, which way is this thing going, before you choose what you're going to go solve for. Now sometimes we're going to be specific, and we'll ask you for the horizontal velocity. And then no matter which way it might be moving, all we're asking for is Vx. And sometimes we'll be specific and ask for vertical velocity, and even though it might be moving sideways, all we're really asking for is Viy or Vfy, depending on whether it's at the start of the trajectory or the end of the trajectory. But you got to know your terms. When we say velocity, it could be lots of things. It depends on which way it's moving at that time. All right, so enough with the suspense. What if it is right here? You're looking for Vxy because it's moving at an angle. So on this slide we told you you got to find Vx and you got to find Vfy first, but once you have that, this is how you would do it. This whole diagram represents the velocity sideways and the velocity up and down at the moment that you're looking at. Because the speeds would be different sometime later. But at that moment, you could draw a vector diagram of how fast the object's going sideways and how fast the object is going down. And when you add them together, geometrically, you'd get Vxy. Now, one really nice thing here is you're not going to have to draw a perfectly scaled vector diagram, because Vx and Vfy are always going to be at a right angle to each other. So you know this equation by a better name. It's the Pythagorean theorem. It's a squared plus b squared equals c squared, right? Only in this case, we're going to want to know the hypotenuse. It's going to be Vxy. You'll always have to start with Vx and Vfy to find it, or Viy if it's at the start of a trajectory. So you can plug in either Vf or Vi in the y direction here, and Vx there. Square each, add them, take the square root, and you know how fast it's really moving. Now remember, velocity isn't just speed. Velocity is speed with direction. The way we're going to give the direction is with this angle right there. We're going to measure the angle you can see down from horizontal if it's moving downwards towards Earth. That can also be calculated. You can do it on your calculator with that equation. You may remember SOHCAHTOA. The tangent is equal to the opposite over adjacent. So if you take the inverse tangent of the opposite over adjacent, which would be Vfy over Vx, because that's the opposite side and the adjacent side to that angle, then you've got that angle. Do be sure to put your calculator in degree mode.